as the aggregate lake effect. Basically, the concept states that neighboring lakes all have an aggregate influence on the subsynoptic environment. Aggregate warming during a cold air outbreak results in a aggregate lowered pressure. These aggregate troughs can interact with synoptic disturbances and can result in smaller mobile surface troughs that enhance existing LES bands and potentially change the mode of convection of LES bands that are already underway. This two-part schematic shows a subsynoptic scale trough over the large western lakes, the kind of a trough that occurs during cold air outbreaks when the lakes are warm. This so-called aggregate trough is pretty much a western lakes phenomenon. You can see it here extending from east to west out over northern Wisconsin. Notice this feature that's meant to represent a lower to mid-tropospheric disturbance that's approaching the area, maybe a 700 millibar jet max or a 500 millibar shortwave. The toggle shows this disturbance has interacted with the aggregate trough, and an enhanced mesoscale trough is formed and is now moving through Wisconsin. This feature is known as a mobile trough and oftentimes causes mild snow, light snow over land masses, but very heavy snow over lakes, as we'll see in a minute. Greg Mann, one of the co-authors of this session, did a lot of the research on mobile troughs. These maps are from his dissertation and show the setup for a case that began on the 18th of December, 1996. What we're looking at here is we're looking at 500 millibar analysis in the upper left, 850 in the upper right, and down here in the lower left, we're looking at surface data with M Slp superimposed. In this case, we're analyzing at 2 millibar contours, which Greg says is often necessary to identify these mobile troughs, although in this case, quite clearly the mobile trough is visible. Notice the aggregate trough that is in place, quite strong, and the 500 millibar trough that's approaching from the west. 12 hours later now, at 0Z on the 19th, the 500 millibar trough is now moving across Wisconsin, and a mobile trough has just begun to rotate across Wisconsin as well. And note at 850 millibars, the 850 millibar front has passed through the area, and the temperatures are very cold. Here at Green Bay, we have a minus 22 degrees Celsius. 12 hours later, at 12Z on the 19th, there's now a full-fledged mobile trough over eastern Wisconsin. It's beginning to really rotate across the state here. Pretty good pressure falls associated with it. The upward fluxes of heat and moisture are such that the air at 850 now is beginning to warm. Now at Green Bay we have minus 18 degrees. In fact, it's even beginning to moisten a little bit. The dew point depression before was 22. Now it's only 19. This is occurring behind the front, so the mobile trough is actually affecting the boundary layer all the way up to 850. Finally, at 0Z on the 20th, that's the late afternoon of the 19th in real time, the mobile trough is moving into Michigan. Right in here, mobile trough is beginning to move into Michigan. Mobile troughs most frequently affect snowfall over Lake Michigan, but though they're harder to detect, they do have effects over the eastern lakes as well. Lake Erie and Lake Huron often have single bands in place in these kinds of situations with southwesterly flow, and the mobile trough may be more of a disruption than anything else. This is the 6.7 micron water vapor loop from the 19th. Two things to notice here. First, the 500 millibar trough is quite easy to follow. You can see it here as it moves through Michigan, moves through Wisconsin, and then on into Michigan toward the end of the loop. That's pretty much as you'd expect. But the second thing to notice is that you cannot see deep enough into the troposphere to track the mobile trough. This is a 10.7 micron infrared window channel, and I'm going to use the choose an enhancement feature on the controls frame here. I'll choose the IR Ramsdis color table, and we'll wait a second here while it comes up. In the absence of upper cirrus, you can use this channel to pick up the subtle effects of the mobile trough as it begins to move across the cool, dry landmass in Wisconsin. I'm going to stop the loop near the end here, actually about 2/3 of the way through. and point out the enhanced cloudiness that's associated with that mobile trough. It's right in here, and if you watch that, I'll sweep back and forth a little bit. And that's that mobile trough. That's how subtle the mobile trough oftentimes looks on the 10.7 channel. The cloudiness oftentimes has snow flurries associated with it over the drier land, but it isn't until it reaches Lake Michigan that its effects become important, as we will see in a minute. This is the visible loop from the day of the 19th, and illustrates another of the important points with these mobile troughs. Once again, I'm going to enhance this. I'm going to use the MB curve from the selection menu here. This is a thin cloud mass in southeast Wisconsin associated with the mobile trough. Notice that we are not looking at a multi-lake band effect, where maybe multiple bands from Lake Superior stretch across the UP of Michigan up in here and cross into Lake Michigan. We just have a kind of an amorphous cloud mass that at the time of this loop, we're getting some light snow flurries here in southeast Wisconsin. The mobile trough is simply a weak mesoscale feature with pressure falls on the order of 3 to 4 millibars, and it's nothing more than an enhanced subsynoptic wave, if you will. Okay, once again here we're looking at 10.7 micron infrared data, and I'm going to enhance that with the IR Ramsdis color table. This loop shows the mobile trough as it actually reaches the area of Lake Michigan and begins to interact with the latent and sensible heat fluxes that are taking place there from the lake. You can see cloud tops get appreciably colder over the lake, and there's snow along the eastern shore, which increases dramatically as this mobile trough gets into the area. The radar reflectivity loop from about the same time period shows another common characteristic of the precipitation associated with these mobile troughs. Namely, there's a change in the mode of convection from a weaker multiband event that was in place prior to the arrival of the mobile trough to a much more intense single band storm, which you can see the transition happening right here, and then the whole second half of the loop shows this very intense single band coming into the southwestern counties of the Grand Rapids CWA. And here are the snowfall totals from that short period from Greg's case. Notice the small area that received 3 to 4 times more snow right in here than those counties exposed only to the earlier multiple bands, 3, 4, and 5 inches here along the shore, as opposed to 12 and 20 inches here inland, where that single band event set up as the mobile trough went through. So in summary, warm lake temperatures within a very cold air mass along the western lakes can induce a subsynoptic scale low pressure trough with associated vertical motions and fluxes. Greg's done some studies and found that these events are climatologically frequent. They happen on average 33 times per year, and on average the pressure falls may be 3 or 4 millibars. They can be less, can be a little more, but generally between 3 and 4 millibars. Features to look for: look in advance for the MSLP trough associated with the western lakes. That's going to be your greatest clue, because, point of fact, these features, especially the mobile troughs, are fairly subtle, as we'll show in a case study in a bit, are fairly subtle and difficult to find. They're most easily found using a blend of satellite imagery when there's no overlying cirrus cloudiness. Surface winds, pressure, temperature, typical things. They're most difficult to identify aloft because you're looking for subtle features that are embedded in strong flow. The lake aggregate mobile troughs result in meso-alpha scale plumes of heat and moisture, changes in winds, temperature, stability, precipitation. They generally begin over the western lakes, affect Lake Michigan most frequently. They can affect the eastern lakes, but oftentimes on the eastern lakes they're a disruption to an otherwise well-ordered single band event events that are coming off of Lake Erie and Lake Ontario, southwesterly flow being associated, in fact, with that aggregate trough. Today is going to be focused on the Grand Rapids, Michigan CWA. It's going to involve a mobile trough. This case took place in late December 2001. It's a pretty, we interact pretty vigorously with the class in the live teletraining session, but of course we can't do that here, so I'll just point out the places where we do interact. This is the date and time here in the lower right-hand corner of the frame. What we're looking at here is the Eta 500 millibar heights, vorticity, and winds. And we're going to be forecasting, doing the long-range forecast for the morning of the 27th. In other words, 24 hours down the line. But this is the initial analysis on the 26th, and we see a trough here over the CWA. Here's the GIR CWA right in here. Pretty vigorous vort max, and as we step through the forecast time period here in 6-hour increments, we see that the trough moves off to the east out of the Michigan area. We get to 06 on the 27th. This is the 18-hour forecast. We now see another shortwave, a smaller, less vigorous shortwave coming through Wisconsin at this time, and by 12Z we see small but pretty intense shortwave now crossing over Lake Michigan with the leading edge on shore in the Grand Rapids CWA. Finally, we get to noon, about midday the next day, and we find this shortwave has also moved quickly across Michigan and out of the area. This is the visible imagery for the morning and actually early afternoon of the 26th, and it shows basically we're in a westerly flow regime, and we've got a multiple band event in progress. It takes up most of the day with light to moderate snow over the western half of Grand Rapids CWA. Give you an idea of the what's taking place in advance of what we're going to be forecasting for. You notice here over Lake Erie we have a pretty good single band event in place. There's a good band going out over the Buffalo, going out towards Buffalo there. Here's the Eta M Slp surface temperature and winds, again beginning at 12Z on the 26th, and we'll walk through the 30-hour forecast here to show you how things evolve. Basically, to set things up, remember at 500 millibars we had a pretty good trough over the CWA. At the surface we can see a reflection of this trough, probably a mobile trough, and it will move out to the east through the forecast period along with that upper trough. Thing to notice here, one of the important things to notice is this baroclinic zone along the northern edge of the lakes. Even though we have a mobile trough that's kind of confusing, gives you kind of a confusing idea as to whether or not there's an aggregate trough or aggregate low in place over the western lakes, this baroclinic zone is a pretty good clue as to the fact that there probably is one. We also have a little bit of a cold air feature here over eastern Lake Michigan. As we step through the time period here, we see the aggregate low begins to set up again over the western lakes, and by 06Z on the 27th we now have pretty good low pressure now setting up over the western lakes, and going on to 12Z this low pressure becomes a lake aggregate low, and we see the hint of a troughiness here that might be associated with that second wave that's coming through. Interestingly enough, we're using an 80-kilometer grid here, and one of the things we ask the class here at this point is, with an 80-kilometer model grid, what sort of a size disturbance would it take to be able to resolve it completely? And of course, the answer we're looking for is an 800-kilometer wavelength feature. Typically, mobile troughs are on the order of 200 to 300 kilometers. The point here being that 4 delta X, 5 delta X can partially resolve disturbances, and in this case it looks like the Eta is picking up a little bit on some sort of a trough moving through here. So just because you have, of course, a grid resolution doesn't mean in these subsynoptic events you're not going to be able to see some sign of what you're looking for. And again, the real secret to locating a mobile trough is recognizing the situation as it's setting up. We've got the Eta 850 millibar heights, temperature, and winds here. Same forecast time frame, beginning at 12Z on the 26th, and going through the 30-hour time frame, we see that the 850 in this case pretty much reflects what's going on at the surface data. at the surface rather, and no surprises here. The next thing we want to show is the sounding from a grid point in the Grand Rapids CWA near Grand Rapids, and we're looking at hourly forecast data here, a loop of hourly forecast data, and I'll animate that now. And it basically shows the temperature and dew point profile here, along with a parcel that's a lake-induced parcel. If you look over here on the lower left-hand side, you'll see a lake and some lake-induced parameters. It's from the warmer lake. Adding the warmer lake to the land sounding grid point, we find the parcel is quite warm relative to sounding, of course. Some of the things we notice on this loop of the sounding here, this hourly loop, is throughout the day. Let me stop the loop now and go through the day. This loop begins at 7 a.m. on the 26th and goes hour by hour. And as we see throughout the day on the 26th, the boundary layer kind of raises appreciably, and the air mass gets warmer as we go through the period. Till we get to late afternoon, the boundary layer once again begins to drop lower. And also notice, when we animate this, notice that the winds are pretty much unidirectional. And if you remember back from Lake Effect Snow 1, that's one of the things we want for a good Lake Effect Snow event, is to have unidirectional shear with height in the boundary layer, and that's what we've got, or unidirection in the boundary layer, and that's what we've got here. This is also buff kit. It's the cross section. It's a cross section which begins at 12Z on the 26th and goes from right to left to 12Z on the 27th. And what we're showing here is the lake-induced top of the boundary layer with time, how it changes with time. In this magenta color here, we're showing the area that's favorable for dendritic growth. This greenish color here is the area of 75% or greater relative humidity that coincides with the best dendritic growth. In red, we're showing upward vertical velocity, and in blue, downward vertical motion. Basically, we ask one of the offices to give us a description of what they see on this presentation, and when they think the most favorable time for heavy snow is for the Grand Rapids area. And basically what we're looking for is during this time here near 0Z on the 27th, we have maximum upward vertical motion right in the dead center of the best dendritic growth, which produces the best snowfall. With the maximum vertical velocities, upward vertical velocities being in that dendritic growth area, there's also a pretty good chance of graupel occurring, which is also good for heavy snow. And then after 0Z, we begin to get a drop-off here. We get a little secondary max of vertical velocity here near about 0.9, but it's a little bit low compared to the best crystal growth area, and so it may not produce very much, at least according to the ADA. Now, looking at the surface M Slp analysis overlaid on the 6.7 micron water vapor imagery, there's several things to notice here. First, there's a pretty good aggregate low over the western lakes, and it's almost 0.9, and there's actually a sign of troughiness in the surface analysis here, even in this crude of fashion. But what's really important is we see that this shortwave trough here looks to be quite a bit more vigorous than was initially implied. Remember that we had just a little, at least on the 80-kilometer analysis or forecast that we were looking at, 80-kilometer model run we were looking at, we just had a little bitty hint of a shortwave here in central Wisconsin, and the shortwave is actually quite a bit more vigorous than had been implied on the forecast. This is a hand-drawn analysis from that time from 9Z on the 27th, 3 hours before the 12Z, when the trough was supposed to be along the eastern shore of Lake Michigan. And what we see when we do the hand analysis, we actually see two troughs here. We see pretty good trough is already into the Grand Rapids CWA. There's also kind of a secondary trough back here in central Wisconsin. There's a lot of indications of light snow throughout the area at this particular time. But let's go on now and look at the RUC 80-kilometer analysis and forecast and see if that showed any signs of these two troughs here that we found. Okay, so here's the RUC analysis, actually the 3-hour forecast from the 00 run, 27th of December 01. 80 kilometers, and again we have a trough at 03 right along the eastern shore. And that's not unusual in this kind of a flow regime because the warm air associated with the lake often causes a little bit of downshore troughiness. But notice here this fairly large trough, even on the 80-kilometer analysis now, moving through central Wisconsin. And as we step through 3-hour time, this is 06, you can see the trough moving along here through central Wisconsin until finally at 09, we have a very sharp trough now. What appears to be the mobile trough is now phased with that eastern shore trough, and we have a pretty good-looking trough for an 80-kilometer analysis. And then we go to 12Z on the 27th, and we see the trough moving inland at that time. Just a quick look now at the 6.7 micron water vapor data. We showed that a little earlier, but this is through runs from 9Z to about mid-morning, 16Z on the 27th, and we can see that shortwave is very vigorous indeed. And in fact, you can see some enhancement actually occurring, enhancement in the water vapor, and maybe some cloud tops peeking up here on the western shore of Lake Michigan as probably this mobile trough moves out across the lake here. But again, remember that this is not the way to look for mobile troughs, so let's go to the infrared imagery. So what we're looking at here, let me stop this loop. What we're looking at here is we're looking at infrared 10.7 channel 4 infrared imagery from the GOES satellite, and that's superimposed on that are the surface observations. And one thing at this point we get very interactive with the class. We try to elicit some recognition of the mobile trough coming through Wisconsin. This is a very subtle case, and it's pretty difficult to see. We focus the class's attention sometimes on Wisconsin Falls here and other times in Oshkosh, and if you watch these two observations, you'll see that as we go along through time, you can see that the pressures begin to drop at Wisconsin Falls, 0.03 to 0.025, 10.0025, and we've got a 26 here at Oshkosh, and then watch those two pressures as time goes on. Now we have kind of a bit of enhancement on the infrared imagery here, and you want to be looking for that, but you also want to be looking for dropping pressures and reports of increasing snowfall. And again, the real secret, there's a little bit of snow now at Wisconsin Falls, and the pressure is continuing to drop. Remember that the real secret to locating these mobile troughs sometime is the anticipation, knowing that the aggregate trough is in place over the western lakes, knowing that there's a short wave coming through, and then maybe looking at the models and trying to get some timing out of the models. The RUC implied that we might be looking around 09Z. Right now, we're looking at 0730 on the 27th, which is about an hour and a half before the mobile trough is supposed to reach Lake Michigan. So let's continue forward here through time. Let me erase that. Keep watching these obs again in Wisconsin, and you'll see that the pressure continues to fall. And now we're picking up just a few more one-flake snow obs here as we go along. Now we've reached. Let me move the arrow. As we reach 8:45 and then 9:15, we begin to see an enhancement here out on the lake, and the enhancement grows by 9:30. And as the loop continues now, it's quite clear that that this mobile trough has reached the eastern shore, and you'll begin to see the infrared imagery fill in as the mobile trough sets up and changes what had been a multiple band event into a single band heavy event over the southwestern tip of the GRR CWA. So important thing to learn from this loop here is that oftentimes as these mobile troughs move across these dry land masses with dew points in the teens, of course, and very cold temperatures. They're oftentimes hard to see, and the only clue you'll get will be these dropping pressures, subtly dropping pressures, and the one-flake snow as the disturbance goes through, and then all of a sudden enhancement over the lakes. And similar to the case that we looked at when we were presenting this concept for the first time, once again we have over the southwestern corner of the Grand Rapids CWA here. In fact, it's a little bit larger area this time, lesser totals, but a larger area. We have much more snow where this mobile trough came through and set up the single band event, as opposed to the surrounding areas where they got 2, 3, and 4 inches. Here they got nearly 14 inches. So in summary, lake aggregate troughs are a common feature during cold air outbreaks. Remember, Greg's climatology showed that these things happen frequently throughout the year. The forecast can be modified appreciably when you factor in the potential mobile trough. The snow is enhanced appreciably, particularly when dealing with Lake Michigan, and detection is oftentimes very difficult. First step being in recognizing the pattern. Second step, using a combination of NWP output, satellite imagery, hourly surface obs, whatever you can find to look for signs of the mobile trough and try to track it and see if it's on time. Several examples of how the warm air over the large western Great Lakes can form an aggregate trough and can interact with oncoming small-scale disturbances at 7 or 500 millibars and intensify snow along Lake Michigan sometimes and disrupt it along the smaller lakes to the east. So thank you, and that's the end of the session.